Welcome everyone back. The switch on is an advantage. So it seems that everyone wants to be a happy insurance client here. Now we'll listen to a talk from La Mobilière. It's probably one of the best insurance companies in Switzerland. So our two next speakers one is Eva Morstein. She's a data scientist at La Mobilière, and Michael Gross, a data scientist and an ML ops expert. I received 5, 6, 7 cards of their bio, so I'm not going to read that. I think both are top experts in their field, and the talk is short, so the floor is yours. Welcome. Thanks.
Well, thanks for the introduction, short and sweet. And yes, we want to talk with you about how we use a product recommender system to make our customers even more happy. And we worked on this case on the last 1 year, I think, and we'll try to keep it short and keep it in 10 minutes. Let's see how we do. So maybe you wonder, why do we think that a product recommender system will make our customers more happy? Well, let me give you a sort of background to the insurance business. Most of our contracts are still concluded offline, meaning that an insurance advisor has an appointment with a customer and then he talks about what the needs are and recommends the best suiting product. And, well, we have a lot of customers and each insurance advisor has a lot of customers to handle, and also we have a very broad portfolio. This case focuses on the small and medium enterprise segment, and in this segment alone we have around 1,000 different coverages that can be concluded. So they have a lot of specific knowledge they need to really recommend the best suiting product and really have to invest time before an appointment to know which will be the best product for this customer. So we wanted to make their life easier by giving them these recommendations beforehand so they don't have to invest that time themselves, but instead can focus on really looking through the recommendations, decide, okay, this is something the customer might need, and then prepare accordingly. And the goal of that is also that the customers really get what they need based on similar customers we already have in our portfolio. And we wanted to do this with the emerging field of graph-based recommender systems. So what we came up with was sort of this like 2-step process. We had one model to tell us who the advisors should approach in the next 2 to 3 months. And we had one model to tell us what they should talk about in the appointment. So the first one was a very simple tree-based model, XGBoost, where we included the features of the enterprises, so the type of business, the age, the location, and so on. And this will not be the focus of the talk, because again, we have only 10 minutes. But the second one was the recommender system, and that only based on the contract information of our existing customers, so only what coverages do they have and what coverages do they not have. And these two models combined then gave us a list of upsell-affine small and medium enterprises, meaning enterprises that have a high probability that they will, bless you, that they will conclude an additional coverage in the next 3 months, and enrich this with the recommendations what the most probable coverages are based on the recommender system. Then we had to apply several business rules. One example would be that you don't want to push additional products with a customer that has not paid their bills in the past, for example. And after all these applications of business rules, we then delivered these, unfortunately, manually via mail to the agencies, because it was only a proof of concept, so it wasn't not implemented in a productive system, but nevertheless was used. And to get to the recommender model, for those of you who have not visited a talk about the recommender system today, I'm going to tell you how it was in our case. So mostly if you look on the top right, mostly you have users and they have several items. In Netflix, that would be people who watch movies and the movies they rated. In our case, the users are the enterprise customers and the items are the coverages they might have. And then you want to compare users with another and see, based on similarity, what would be a feasible recommendation for them. Unfortunately, we don't have explicit feedback, so the customers didn't say on a scale from 1 to 10 how good did you find this coverage. No, they just they concluded or they don't conclude it. So this is something called implicit feedback, and we have this binary rating, just ones and zeros. But we have this information for multiple months, and we used this multiple months to train our model. So we had February and March, for example, and trained the model with this 2 slices so that we have the information, does he in the future conclude the coverage or not. And this was, I would not say big data, but we had around 120 million rows in each data set. And one problem or challenge we encountered was this is very sparse data. I mean, you know it, you don't have 1,000 different insurance products, you have 2 to 3, and these 2 to 3 products have 2 to 3 coverages. And the rest, you have zeros in this example. So the data is very sparse. And Michael is going to tell you how we solved this challenge.
Thank you very much. So I will now go into the graph part. You already saw that there's a matrix representation, there's a vector representation, and how to solve this problem best. Well, we heard it, I think, a couple of times today. Using graphs, they capture patterns best. They can learn patterns efficiently. It's a large improvement over convolutional neural networks, which just stick to a fixed grid. So the filtering there is a bit limited. And so we went for this graph convolutional neural network. And we decided for light GCN. The recommenders library from Microsoft has an implementation of that you can easily use with Python. And as explained before, we do not use user or item features yet. We might actually when we go into production mode, but this is a different topic. And maybe, again, the example we had before. So it bases on the neighborhood principle. You see here user 1 and user 2 share 3 items, have 3 items in common, but user 2 in addition has this item 4. And our task is actually to predict, well, should there be also a link from user 1 to user 4? Probably yes, because they already are quite common and similar as they share these 3 different products. And then you can also have the same view from an item perspective. So the 2 items in the middle have 2 common users, so they might be good candidates to be solved in combination. And from these 2 perspectives, we develop 2 different embeddings. One is the user embedding, and the other one is the item embedding. And then you can think of this parameter k. You can tune the neighborhood size, so you can also look at neighbor of neighbors. This will be like k equal to 2, neighbor of neighbors. So you can include a bit more there, but we just use the default settings and went from that. And then finally, when you have these user and item embeddings, light GCN just makes an element-wise product to capture the user-item interaction. And this leads me to the next slide, how the scoring process worked. So the absolute numbers are not so important, but we got scores between -10 and 30, and this is like continuous numbers. And the first thing that interested us is, can the model really distinguish well non-concluded coverages and concluded coverages? And yes, it can. One also sees that we have quite sparse data, so the peak around 0 is much higher than the peak around 10 for the concluded coverages. And then, of course, what we need is some kind of prediction. And the question was, how should we do this? And this we did by defining a threshold that gives us still good metrics. And because after applying business rules, not so many customers were remaining, we just divided this into a highly recommended part. So this is on the right part of the threshold, and the recommended part, because we also want to make sure that insurance advisors also respect our affinity model, where we already select customers that they should approach, and that they do not only sell products which are recommended by our recommender. Of course, hopefully they do also push those products, but this is just from a business perspective. This was also important that we do not completely exclude the coverages on the left side. And this leads me now to our results and next steps. So we got very good feedback from general agencies. There were a lot of appointments, also 2 to 3 conclusions. And you have to see, like in this proof of concept, we restricted ourselves to a certain product, and there were maybe around 60 to 100 customers approached. So this is actually quite a good number. And we also got good feedback that it allows to broaden a bit the portfolio. Maybe also coverages that are not so profitable are looked at, and also new agents get to know the whole portfolio better. And also what we got actually requests from general agencies to deliver one-time deliveries and lists. And now we're actually in the final evaluation phase, and we are also looking into a potential integration into our productive system. So that's all from our side. Thank you for our attention. And I don't think we have time for questions. Right?
Thank you very much, Eva. Thank you very much, Michael. We don't have time for questions, and that was the first time I've seen a presentation from La Mobilière without the funny sketches. But tons of knowledge. Thank you for that.
And we're happy to answer questions in the coffee break.
Yes, you get the nice bottle, and of course you have a booth. So if someone has questions, they will be at the booth of La Mobilière. Thank you.
Thank you very much.